Hello, I'm Reggie York. This is a presentation on using the binomial test when you have before and after data for a dichotomous variable. That's one that has only two categories. At the end of this presentation, you will be able to employ my special Excel file for calculating the binomial test to compare before and after data for a dichotomous variable. That is to say, you have measured your clients before treatment on whether they were positive or negative in their behavior, using drugs, not using drugs, or something of that nature. And you measure them again at the end of treatment. Were they using drugs, yes or no? You have it before treatment and after treatment. That is the situation we're talking about. We want to know if the after treatment data is significantly better. You will know how to use this file to determine the value of p, which will help you determine statistical significance. This means that you have data for a group of people at 2 points in time, before and after treatment, and the data places people into only two categories. I will use the example before and after treatment, but you can use it for any situation where you have collected data at 2 points in time and you're comparing them, and the data comes in the form of a dichotomous variable. You wish to know if the proportion of data in the favorable category at the second point in time is significantly greater than the proportion in the first period of time. Example number 1, you measured 10 clients before treatment began regarding whether or not they had used drugs in the past week, and you measured them again at the end of treatment in the same way. This may be what your data would look like. Before treatment, 2 people did not use drugs, but 8 people did. That's before treatment. 2 people used drugs, 8 did not. After, you found that 6 people did not and 4 people did. So you can see here is the distinctive difference. Those who did not use drugs, that's what you're looking for. 60% of those were better off after, that's better, of course, than the other. So 60% versus 20%. This favors, of course, the after treatment data. Example 2, you have a single client who was measured several times before treatment, we call that a baseline, and several times during the treatment period, and you found a notable slope in the baseline, so you cannot use the standard deviation approach, which would not be appropriate if there's already a progression going on during the baseline period. You will draw the slope from the baseline through the treatment period so that you now have data in 4 categories. Number of favorable recordings in the baseline, number of unfavorable recordings in the baseline, number of favorable recordings in the treatment period, and number of unfavorable recordings in the treatment period. This is what your data may look like. During the baseline, 3 measurements were favorable, 7 measurements were not. Treatment period, 6 measurements were favorable, 4 were not. So this looks like treatment was better than baseline. The statistical question is, was the data for the treatment period significantly better than that for the baseline? What the binomial test does, the binomial test tells us whether the proportion of people or things in a given category is significantly different from the proportion of people or things in the other category. We're talking about only 2 categories now. If we assume that 1/2 of all people are male, but our sample has 60% male, is our sample different from the general population? Is it significantly different? Do we have a unique sample here? Is 60% significantly greater than 50%? Whether that's true or not will depend not just on the percentage, but also how many people are in your data. Our example is 60% favorable different from 30% favorable. Now let's look at, we've talked about statistical significance, but also we could look at practical significance. Statistical significance tells us how likely our data would occur by chance. practical significance is an opinion about the extent that our data is noteworthy. And the point I just raised a moment ago about the proportion of favorable in one period of time versus the other, is that noteworthy? Is that amount noteworthy? And it is a matter of opinion, not a matter of science to decide. It is difficult to have practical significance in the absence of statistical significance, given the basic meaning of failing to find statistical significance. If you fail to find statistical significance, you have not ruled out chance as the explanation for your data. Is it chance or is it real? Is it chance or is it useful? Is it chance or is it meaningful? If you haven't ruled out chance, how can you go down the other road? One caveat: if your data are not amenable to statistical testing, then it should not be tested. But that's a different lesson. Practical significance. The value P tells us about statistical significance. Practical significance lies in the difference in proportions of favorable recordings and the before and after condition. Again, is a 30% favorable versus 60% favorable of practical significance. In other words, 60% were better during the treatment period, 30% baseline. Is this enough of improvement for you to say you have practical or clinical significance? Now you're ready to use the Excel file. You'll load Excel software into your computer. Then you will load the York Excel file entitled York Binomial Test Before and After Dichotomous Variable. So let's go to that file right now. Anytime, by the way, you wish to pause this presentation to catch up, feel free to do that. Here is what the file looks like when you get it. Let me ask you to pause, hit the pause button and read these instructions, and then come back to me and we'll talk about them. Okay, I hope you've read that. So you know to enter your data in these 4 cells right here, right? Let's just throw some numbers in here. Let's say that 20 people were negative during the pre-test and positive in the post-test. They were negative state, positive state. Say using drugs, not using drugs. However, we also found exactly 20 had gone from a positive state and stayed positive. We found that 20 people went from a negative state to negative, meaning they did not change. And 20 people went from being positive to being negative. You can see here 2020, 2020. Well, this is clear. This should be very clear. There is no advantage for the post-test data. There is no difference between the 2 variables of pre-test and post-test. And you can see that the value of chi-square here, 0.025, this, and it says here, if chi-square is at least 3.84, you have statistical significance at the 0.05 level, while a chi-square of 2.71 is significant at the 0.10 level. This 0.025 isn't anywhere close to these two, so obviously this is not of statistical significance. But let's change these numbers here. I'm going to put a 10 right there. And let's make this one a 10, and let's make this one a 5. Now you see that you had 20 people who went from negative to positive. That's what you want to see most. You had 10 people who did not change. They were positive to start with, positive to end with. 10 people here didn't change. They went from negative to negative. And you had 5 people who went from positive. They got worse. This number improved. This number got worse. The other 2 cells stayed the same. So does this mean you have, of course, the one you're looking for is going from negative to positive. That's the largest number. Is this statistically significant? Chi-square value here says 7.84, which is much better than 3.84. Therefore, these data are statistically significant. Okay, well, I hope this was helpful to you in doing your analysis.